Alright, so we're moving on to solving multivariable. This time, guys, they are linear, okay? So they are linear systems. Okay, so it looks something like this. What do you notice I'm adding now? A z. So now we have, that's why it's called multivariable. So we're going to have more than one, obviously. I have an x, y, and a z this time. Okay, but if you notice, if you look at all the equations, what do you not see? Any exponents, because remember I said they're all linear this time. Okay, so they're all linear this time. So one of the things we're going to get used to knowing here is called row echelon form, named after, of course, a mathematician, echelon. Okay, it has what we call a stair-step pattern with the leading coefficients of 1. If you look right here, these red x, y, and z's, notice they're all 1x, 1y, and 1z. Okay, so there's two ways I'm going to show you how to do this. The first way is simple. And actually, the second way is simpler. Okay? So the first way is simple. We're going to use something called back substitution. So if I tell you this, that x minus 2y plus 3z equals 9, and that y plus 3z equals 5, but then I tell you z equals 2. So what would be the easiest way to figure out the rest? Literally just back substitute it. So if I know z is 2, then I can plug that in here. This becomes 3 times 2, of course, is 6, and then I can solve for y, correct? And then if I know z and y, I can go back, substitute it for z and y, and find my x. Does that make sense? Okay, let's do a couple of those real quick, and then I'm going to show you a way to just use your calculator, all right? I'm going to show you a way to just use your calculator. All right, this is an example you just had on the previous page, and like I said, or like we said, I know how to do this. It's pretty simple. We're just going to use something called back substitution, okay? So if this is true, that z equals 2, how do I figure out what? Well, which one do I back substitute in? The first one? No, because then I would have 2 missing, right? So you're going to go into this one. So it's going to look like, fine, y plus 3 times 2 equals 5. So y plus 6 equals 5. Therefore, y equals to what? Negative 1. That's pretty simple, right? Now that I know z and y, plug it into the first one, it'll look like what? Okay, so that's a 2. X minus 2 times negative 1 plus 3 times 2 equals 9. So we can simplify this. This is going to be what? X plus 2 plus 6 equals 9. Obviously, this is x plus 8 equals 9. Therefore, x is equal to what? 1. Okay? So then at this point, people, remember, these are systems. And at the end of the other stuff, what did I always want at the end? A coordinate. But this coordinate has 3 numbers? Actually, yes it does. Okay? And this is a 3-dimensional coordinate. So it would be 1, comma, negative 1, comma, 2. Have you guys ever seen something that looks like this before? It's a 3-dimensional coordinate. So imagine this room. This room is 3-dimensional, right? And do you know why we call it, by the way, 3-dimensional? What does a dimensional mean? What is a dimension? Dimension is a length, right? So on a flat piece of paper, how many dimensions is it? It's only 2, a length and a width. But in our world, a 3-dimensional, we have length, width, and height, right? So if you want to think about it, it's more like x, y, and z. So technically, Arturo's head is a point in this 3-dimensional room, correct? And I could literally give you a coordinate, and if I say over there by Jonah is 0, okay? So that corner is 0, right? So look how I would say. I say, let's just say this is 5, right? This is 5 on the x-axis. We'll say that this is 4 on the y-axis. Does that make sense? But that would be on the floor. But then on the z-axis, which is the height one, I would come up. So let's just say 2 or 3, right? Does that make sense? So when you see a coordinate like this tells you, oh, this is a 3-dimensional coordinate, which means it has an x, a y, and a z. Okay? So I can literally create a scatter plot with all your heads as points, right? And that's what you do. If any of you ever going to get into graphic design or anything like that, you use three-dimensional points, okay? Any questions about that? This stuff's pretty easy, right? Why don't we try one more just to make sure you got it down? Try this one on your own. I'll give you a couple seconds to figure that out. And then we'll see if we get the same answer. Alright, so this is pretty simple. I already know that z is negative 2. Okay, so that's 1. So it would look like what? 6y minus 5 times negative 2 equals negative 8. That would give me 6y plus 10 equals negative 8. That's supposed to be an 8, okay? So 6y is equal to what? Negative 18. So y is equal to negative 3. Everybody get that? Okay. And then finally, if z is negative 2 and y is negative 3, so then this looks like 4x minus 3 times negative 3 minus 2 times negative 2 equals to 21. So that would give me 4x plus 9 plus 4 equals to 21. So that would give me 4x plus 13 equals to 21. Subtract the 13, so that would give me 4x equals to 8. Therefore, x is equal to 2. So in the end, my answer is what? Which again is a three-dimensional coordinate, right? Which is okay. Is there a fourth dimension? Theoretically. Okay. So, have you ever seen that movie Flatland? Your geometry teachers ever showed you that? It's the silliest cartoon / movie in the world. It's a bunch of shapes, like they're literally talking to each other. And yeah, so they live in a flat land, obviously, right? So they live in the second dimension. And they don't believe that another dimension exists until this sphere comes around, which is the third dimension. And then he shows them the power of the third dimension. And of course, they're all whatever now. And then he laughs at the fact of a fourth dimension, right? But then they kind of give a little hint of something called a hypercube, which is a theoretical fourth dimensional shape. It looks like a cube that goes inside and outside of itself because it's moving. Because theoretically, the fourth dimension would be time. Because you know how we have length, width, height? And so since time is continuous, it would be moving. So, and I say theoretical because obviously we haven't found it yet, right? But it has to technically. Most of our mathematics, most of our high level mathematics, depend on the fact that there are n dimensions. Because if there weren't, then a lot of our mathematics wouldn't work. But it does. All right. So are we good with this easy stuff? Right? Okay, let's make it easier. So now, what if I give you this? So now, I said it's going to be easier. But by the looks of it, it looks more complex. Why? Good, because there's no given one here, right? So in this case, I don't just straight up tell you, oh, z is this. So in this one, it just says x plus y plus z equals 6, 2x minus y plus z equals 3, 3x plus y minus z equals 2. So I don't give you anything straight out that you can do. What's up? What do you mean? So there's a lot of things we can do here. We can actually use our methods that we already know, which are substitution and elimination. Like, for instance, do y'all notice that if I just look at the bottom two, the y and the z would cancel if I add them together, which means I'll be left with an x, which means I can solve for my x, correct? Which means I'll know my 1. But then I'd have to figure out another, and then if I look at, since I'll know x, correct, at that point? And then what if I add the top two together? I get rid of the y's, and I'll know x, so I can solve for z. And then I'll know x and z, and then I can solve for y, right? Correct? So I can use my old methods. And I'm not going to force you to do that because that's actually a lot of work, okay? So what we're going to do is something called a matrix. You guys remember matrices from Algebra 2? Okay? So we're going to use a matrix, okay? And the first step is first you have to create your matrix, okay? Okay? You have to create your matrix. So we're going to make one matrix out of this whole thing. So first of all, you got to figure out the size. Okay? Matrices are always rows by columns. Okay? When you figure out a matrix, it's always rows by column. How many rows does this thing have? 3. Rows go this way. Columns, just like in a building, go straight up and down, right? So it has how many rows? 3. And how many columns? It would be 4, because you do have to include this one. Okay? So this is going to be a 3 by 4 matrix. Okay? The great thing about matrices is basically it ignores the variables. Okay? We're going to ignore the variables. So all you have to do is, by the way, that's create. Rows by columns. Okay, so you're going to create our matrix. And we said it's going to be a 3 by 4. So all you put are the numbers, guys, are the coefficients of what your equation, your system looks like. So like, what would be the first row? 1, 1, 1, 6. The next one? 2, -1, 1, 3. And the last one? 3, 1, -1, 2. You guys remember doing that? Any questions on that? I got a question. What if I was like missing a y? I got to put a 0 in that place. Does everybody understand that? So you got to understand that this is my x column, this is my y column, this is my z column, and this is my solutions column, right? Okay, so first we're going to create our matrix. Now, using matrices, there's actually a lot of stuff that I can do. I can do a lot of algebra and stuff to this, okay? And normally, like in your college courses, you're probably going to learn how to do that. But it's a lot. So what our goal is to do this. With matrices, we are to try and manipulate these numbers somehow so that basically all I get is a 1 here, a 1 here, and a 1 here because that would represent x, y, z, and then a 0 everywhere else so that I'll know, oh, z is this, y is that, and x is that. Does that make sense? Now, like I said, there's a lot of algebra and manipulation I can do to that, but I'm not going to force us to do that either. This is the one out of many times where I'm actually like, you know what? Let's just use the calculator. The calculator does this for us, so let's just use the calculator, okay? So, in your calculator, okay, does everybody know how to make a matrix? Seconds. Actually, I'm going to show you an even shortcut in the calculator first. But before that, so, okay, we're going to create our matrix. So that's what you did. We created our matrix. And then we're going to use the calculator to solve. Now, the command to solve in the calculator is this. Okay? This stands for reduce row echelon form, which is like at the beginning your vocabulary word that you copied down was, remember, it was called row echelon form, right? Which was where z was this, y was that, x was this. So reduced row echelon form, basically I'm telling the calculator, hey, I want you to reduce row echelon form this matrix, okay? So let me show you how to do that. So you pull up your calculator. First of all, make sure it's cleared. Make sure you cleared it so that everything is normal. If you go to second x to the -1 power, you see what it says in blue? Matrix. And then I'm going to go to math. If you go all the way down to, I believe it's letter B, you see how it's RREF? That's the reduced row echelon form. So you're going to press enter on that. And then it's going to say, okay, give me the matrix. So before you used to have to go and create the matrix in that matrix thing we're used to, but with this new update, if we just do alpha zoom, it knows that I'm going to use a matrix. So first I have to give it the size. What size was this one? So you're going to go to row, press enter on 3, go to columns, press enter on 4, press OK, and it's going to set you up with a blank matrix. Now, help me out because I don't want to go back and forth. Put the numbers. 1, and then press the right button. Don't press enter. If you press enter, it's going to be too much. So 1, 1, 1, 6, and just keep pressing right, and it'll take you down to the next row. 2, negative 1, 1, 3, another 3, 1, negative 1, 2. So when you're done, you should basically have the matrix that you created out of your system. Has everybody got that? And so now I'm telling the calculator, look, I want you to reduce row echelon form this matrix. When you press enter, bam. Okay? So what you end up getting is this. You get another matrix. You get another matrix that looks like this. Now, remember guys, what was this column? X. What was this column? And what was this column? And then this, of course, was my solutions, my answers. If you read it correctly, do you see what this is saying? Z equals to 3, Y equals to, and X equals to, because remember, this was X, this was Y, this was Z. Right? So you get X is equal to 1, Y is equal to 2, and Z is equal to 3. Okay? So it does all the work for it. Now, I do want to point some stuff out. Let me just kind of give you some. This right here, this matrix right here, this is called your identity matrix. Identity matrix. Because basically it's telling you, okay, here's your X, your Y, and your Z, and everything else is 0. Right? So it's identifying your variables. Okay? It's called your identity matrix, and we already said that this was, of course, was your solutions. Okay? So you see how easy this is? So what's the important part here? Making sure your matrix is correct. Okay? Because I can technically put in any numbers and it'll answer it for me. Right? But I just don't. You got to make sure that that matrix, that first matrix, is correct. Okay? The biggest problems for students are they forget to put a negative, or they're just not reading this correctly somehow. Okay? Because remember, I can mix and match my variables. I can make some variables not there, so that would be, of course, a 0, and all that good stuff. Any questions? Pretty simple stuff, right? Why don't you try this one? Try this one on your own. Actually, first, before we do the calculator, first step is to write out the matrix. So let's make sure we all can do that. Okay, so help me out for this first step. First of all, what's the size? Also a 3 by 4. Okay. So what would it be? Did everybody see what he just did with that? Right? Now, is it always going to be a space there? No, I'm just helping you out. So this one. Okay? So, now I need you to go RREF, reduce row echelon form, this matrix. And tell me what you get. I'm going to walk around now and help you out if you are having trouble sticking this in the calculator. Alright, so if you do this correctly, of course you should get your identity matrix. And then what did you get? So if you do this correctly, you get your identity matrix with your solutions. And so now interpret this. What does this mean? Okay? So this is what I want to see, and then of course you can give me the three-dimensional coordinate, which looks like that. So guys, when you do this, I want to see two things. At least, because I mean the calculator is doing all the work, right? So what you're going to show me is, first of all, this, which is the first matrix that you created, and then this, which is what the calculator gave you as the answer, and then of course I want to see your interpretation. Okay? Because I promise I'm going to get mistakes where it's like, oh, x is -1, z is 1, and you know what I mean? So I want to make sure that you can read the calculator correctly. All right? So this is what I want to see. You don't have to show me this, but I want to see what you created, what the calculator gave you, and what that means as part of your work. Does everybody understand that? Any questions? You sure? You good? So you don't need another example? All right. Your call. All right. So again, it's just the same thing. You're going to use matrices to do this, to solve these multivariable linear systems. Okay?